Hello, 안녕 class. So today we talked about proportional and non-proportional relationships, and we discovered what they did, how they affected us while we're learning it. Now we're going to put them side by side from a graph, a table, and equation, and compare the two. Okay? So for a proportional graph, the graph passes through the origin. So it's going to look something like this. Because as you can see, it crosses through that origin 0, 0, home, right? It passes through that origin. It has to cross it, touch it, everything, okay? So the opposite is that the graph does not pass through the origin. So let's check out a graph that doesn't pass through the origin. Bing! Bada boom, bada boom. It passes the y-axis, it passes the x-axis, but look, the bullseye is not crossed by the line, so this is non-proportional. It has to go through the origin. It has to hit it. Okay? It can't just brush up against it. It has to go through it. Okay? The thing we can do, which I showed you yesterday's video, is to see if the ratios are equivalent. Alright, so let's check it out, shall we? Okay, so if we look, we have this thing. I don't know why the line's there, my bad. Okay, anyways, we have this thing, and we're going to look at the equivalence. So, distance versus time. So, let's check out the slope, for instance, not the slope, but the distance over time. So, we have here 6 over 3, the ratio, which equals 2 over 1. Here we have 12 over 6, which equals 2 over 1. And here we have 18 over 9, which equals 2 over 1. Ah, all of them are equivalent. That means the ratios are proportional. Okay? So that's a proportional relationship. So what do you think is a non-proportional relationship? It's when the ratios are not equivalent, right? They are not equivalent. They do not equal each other. Okay? Let's check it out. Okay, let's see if they're proportional. Now, another thing I forgot to mention is we don't want to see if this is a proportional ratio. We don't want to use 0 because anything divided by 0 is undefined, right? So it's always going to be undefined. So we don't want to use 0. We always want to start with the thing without the 0, okay? So let's look at this, 10 over 3. Okay, we can't simplify that anymore. So then we want to look at the next ratio, which is 16 over 6. Let's see, by reducing it, what we get. So 16 divided by 2 is 8, and 6 divided by 2 is 3. That is not the same thing as 10 over 3, right? So we just have to find two relationships that are not equivalent, and then we could call it a day. So that table is not equivalent, so it's non-proportional. That's an example of non-proportional relationship. Let's look at it with an equation. So, Alright, so if we look at the very first slide, remember proportional goes to the point 0, 0. So that means my y-intercept is 0, right? Because remember the first slide tells me that it went through the point 0, 0. So I know that with proportional relationships, my y-intercept is always 0. Okay, so for example, y equals 4x. I mean, I could put plus 0 if I want, or I could put nothing there, right? And my non-proportional always has a y-intercept of some number b. Okay, that's not 0. Okay, so b is not 0. So it's never going to go through the origin, but it's always going to go through some other point. For example, y equals 4x minus 1. That's non-proportional because it doesn't have the point 0, 0. It doesn't have a y-intercept of 0. So any number besides 0 that's a y-intercept is going to be non-proportional. Do you see how all this is coming together? Alright, here's my try it. I want the first one to be, just draw me a graph that's proportional. 2, give me a proportional table. So give me a table that's proportional, where all the ratios are equivalent. And 3, give me an example of a non-proportional equation, where it has a y-intercept of something other than 0. Okay, I will see you tomorrow. I hope you have a great day. 안녕, 선생님. Goodbye.